Okay, let's go to English class for a moment. In English, and more generally in natural languages, we have a grammatical word type called a conjunction. Now, most of you are too young to have watched Schoolhouse Rock, but if you had, you would immediately be thinking, conjunction, junction, what's your function? And its function is to connect words, phrases, or clauses. Now, so far, in logic, we have 4 conjunctions. One of them, confusingly enough, also called conjunction. I apologize for that, but we're stuck with it. Blame the 19th century. That's usually a good rule of thumb. When something is confusing in math, it's because someone thought it was a good idea in the 19th century, and now we're stuck with it. So, the 4 conjunctions that we have in logic are the conjunction, which is P and Q, which we write P, this upside down V symbol, Q, right? It's like a capital A but without the line across it. Disjunction, we say P or Q, and we write P and then this V shape, Q. The conditional, we say if P, then Q, and we write P, an arrow that just points to the right, Q. And the biconditional, we say P if and only if, Q. And we write P and then an arrow in both directions, Q. There are lots of other words in English that we might use to connect clauses, independent clauses, separate simple statements. Do we have extra symbols for those? Well, no, and here's why. Let's take a look at the truth tables again. Conjunction is true when both of the simple statements are true. It's true in one row. Disjunction is true when at least one of the simple statements is true. And a conditional is true when the then part, the consequent, is true, or when the if part, the antecedent, is false. Both of those are true in 3 rows of the truth table. The biconditional, if and only if, well, that's true if both parts are true, or if both parts are false. That's true in 2 rows. It turns out that by playing around with some knots, as we're going to see later on, we can get any set of truth values we want. In fact, it'll turn out that conditional is something extra that we don't even really need, although it's very helpful when we're trying to translate a natural language. So these 4 connectors, these 4 symbols to combine statements, will actually turn out to work for just about any combination of simple statements that we can make in English. If we can't get there using these connectors, there must be something more going on than simple computation of truth values. So, okay, what if we have a different word in English? What if we have a different conjunction? We can use the truth tables to figure out how to symbolize it. So suppose we have the statement, I wanted to go shopping, but the store was closed. Our connecting word, our grammatical conjunction, is the word but. How do we understand that? Well, we have an intuition into what this sentence means in English. Let's see if we can put that into truth table form and then match it to one of the statements that we see. We have two simple statements here. I wanted to go shopping. We could call that P. And our second simple statement is the store was closed. We can call that Q. So, thinking about the truth values of P and Q, what combination of truth values of P and Q will make that compound statement true? So suppose I really did want to go shopping, so P is true, and the store really was closed. Q is true. Well then, the compound statement is true, right? I really did want to go shopping. The store really was closed. That but in there is telling me something about the store being closed causing me to not be able to go shopping, but that has nothing to do with the truth values of the propositions. That's just some extra meaning that's being imported into the English sentence. Okay, what if I wanted to go shopping, but the store was not closed? Well, then I would have just gone shopping and I wouldn't be telling you this sentence, right? If I wanted to go shopping and the store was not closed, I would not say I wanted to go shopping but the store was closed. If I did, I'd be lying. The compound statement is false. If I wanted to go shopping is false, I didn't want to go shopping, the store really was closed, well, I didn't really want to go shopping. I discovered the store was closed. I was relieved. But now when I say, oh, well, I wanted to go shopping, but the store was closed, again, I'm lying. That statement is false. And it's definitely the case that if you come home and find me sitting in my pajamas at 3 in the afternoon, and I say, I wanted to go shopping, but the store was closed, but actually I wanted to sit in my pajamas at 3 in the afternoon, and the store was open just fine, I'm certainly lying. If I didn't want to go shopping, the store was open, that sentence is a lie. I wanted to go shopping, but the store was closed is false. So which column in the truth table does this match? Well, it matches the column P and Q. And so that's how we symbolize it. We symbolize the word but exactly the same as the word and, because the truth values match up exactly. The sentence with but is only true when both of the simple statements are true at the same time. So whenever you encounter a conjunction like this, and we're going to continue to use this technique going forward, look at the truth table, see what truth table you're matching, and based on that, just use the symbol for whatever truth table matches, because our goal is to get the calculation right in the end.